Hello students, welcome back. So in this part we are going to discuss about the different reactions shown by aryl halides. So though they are less reactive than alkyl halides, but they also participate in some reactions. So let's see what are those reactions. So now we are going to discuss about the reactions, the chemical reactions shown by aryl halides. Yeah, they show similar reactions to alkyl halides, but only one difference is there. Yeah, though they are less reactive, but they can be made to react under drastic conditions. We have to heat it, we have to provide temperature and pressure and catalyst. So we can make them react. So the reactions shown by them is typically the four type of reactions: nucleophilic substitution reactions, similar to the alkyl halides, reaction with metals, reduction reactions, and the fourth type is a bit different one, that is the ring substitution reactions. So this I'll concentrate more on this ring substitution reactions that I'll explain in the next part, but the first three types of reactions I'll cover in this part, and the remaining one, the fourth one, I'll cover in the next part. So let's start with the nucleophilic substitution reactions. So here you will see the replacement by hydroxyl group, OH group, and cyano group, CN, amino group, NH2. So we'll see these three nucleophilic substitution reactions. So the first one is the replacement by hydroxyl group. So on heating the chlorobenzene, here I am taking the chlorobenzene. So if I heat this chlorobenzene with aqueous solution of sodium hydroxide at 623 Kelvin and at 300 atmospheric pressure. So here I am providing the conditions. So under these conditions, the chlorobenzene can react with the aqueous solution of sodium hydroxide and it yields sodium phenoxide. So this is the sodium phenoxide. So which on subsequent acidification it produces phenol. So finally we end up with the phenol, the final product, and we are getting sodium phenoxide in between. So here this chlorine is replaced by the hydroxyl group. So this is the nucleophilic substitution reaction. So let's see the replacement by cyano group, which is more or less similar to the replacement by OH, but the conditions may be different. Here when heated, I am taking the bromobenzene, when we heat it in anhydrous copper cyanide in the presence of pyridine or dimethyl formamide. So this is DMF, that is dimethyl formamide, under condition at temperature of 470 Kelvin, we'll end up with getting the phenyl cyanide as the substituted product, where the bromine is replaced by the nucleophile, that is Cn minus. So the nucleophile here is the Cn minus, which replaces this one. So it is nucleophilic substitution reaction. So the bromobenzene is giving phenyl cyanide, or which is also known as cyanobenzene. So this is the second type of nucleophilic substitution, and we'll see the third one now, that is the replacement by amino group, that is NH2 group. So in this reaction, the halogen atom of haloarenes is replaced by amino group by reacting it with aqueous ammonia in presence of catalyst, that is Cu2O. In presence of Cu2O, the chlorobenzene yields aniline, where the chlorine is substituted by the NH2 group, the amino group. So this is the other nucleophilic substitution, the replacement of chlorine by the amino group. Okay. So now other type of reaction, that is the reactions with metals. Reaction with metals. So first we'll go with magnesium. So the magnesium, it reacts with aryl bromides and iodides, and it forms Grignard reagents with magnesium in dry ether. So here we take dry ether. So in dry ether, the magnesium reacts with this bromobenzene and it forms this phenyl magnesium bromide, aryl magnesium halide, right? So which is known as Grignard reagent, which is a very famous one. So with magnesium they produce Grignard reagents. So let's see what happens when it reacts with sodium. So aryl halides when react with sodium in the presence of ether, so mostly we take ether as the solvent in many of the reactions, which is the most famous and which is widely used one. So during this reaction what happens is the two phenyl rings unite. So this is one phenyl ring. So I am taking two molecules. So the two phenyl rings from two bromobenzene, this is actually bromobenzene, they unite and they produce a diphenyl along with NaCl or NaBr. So this is the reaction with metal, and this reaction is called Fittig reaction. This reaction is called Fittig reaction, and we have other reaction, that is Wurtz-Fittig reaction, which is slightly different from this Fittig reaction that I will see, that we will discuss in the next slide. That is the reaction with sodium. Aryl halides when treated with haloalkene. So here we take one haloalkene and we take one haloarene. So this is haloarene and this is haloalkane. So when they react with sodium in presence of ether, they produce this one which is stolen. So this reaction is known as Wurtz-Fittig reaction. So the difference is, in Fittig reaction we take only aryl halide, but in Wurtz-Fittig we take alkyl as well as aryl, right? So such reaction is known as Wurtz-Fittig reaction. So next, the reaction with lithium. So aryl halides will react with lithium metal in dry ether and they produce organometallic compound, where the metal is bonded with the carbon of benzene nucleus, and these are also behave like Grignard reagents. They are very strong bases. So they react with acids and they produce benzene. So it will react with acid to produce benzene, because it quickly abstract proton from the acids from other substances. And the next and last one is the reduction reaction. So aryl halides are reduced to the parent hydrocarbon by the action of nickel aluminum alloy. So here I am taking the nickel aluminum alloy in the presence of alkali, where the aryl halide is reduced to the parent hydrocarbon. So this is the benzene. So the substituent of benzene is this chlorobenzene. So the chlorobenzene is reduced to benzene. So bromobenzene is reduced to benzene, like that. So here we use, just remember this, that nickel aluminum alloy and in presence of alkali produces the benzene. So these are about some chemical reactions shown by aryl halides, that is nucleophilic substitutions and reaction with metals and reduction reactions. And the remaining one, that is the ring substitution reactions, that I will cover in my next part. So students, in this part we discussed about the nucleophilic substitution reactions shown by aryl halides. We also discussed about how they interact with sodium, magnesium and lithium, which are metals. We also seen the reduction reactions shown by aryl halides. So in our next part we are going to discuss about the very important reactions for IIT-JEE and other competitive exams, that is the ring substitution reactions. So don't go away, keep watching for my next part.